For 65 through 72, you're going to use the discriminant to determine the number of real solutions of the quadratic equation. So here's the quadratic equation. The part under the square root is the discriminant. If the discriminant is greater than 0, you have 2 real solutions. If it's equal to 0, you have 1 repeated solution. And if it's less than 0, that means that you can't find a real solution. So this has 0 real solutions. So for number 65, you have 2x squared minus 5x plus 5 equals 0. So here a is 2, b is negative 5, and c is 5. So I don't really have to look at the whole quadratic equation. I can just look at the discriminant. So my discriminant is b squared minus 4ac. b squared is negative 5 times negative 5 is 25, minus 4 times 2 times 5, or 40. That is less than 0. So I have 0 real solutions. For number 105 through 112, we're going to solve using any convenient method. For 105, I suggest you complete the square. That's with the pattern x squared plus bx plus b over 2 squared equals x plus b over 2 quantity squared. For 106, I suggest that you factor. And for 107, I suggest that you try extracting the roots. Factoring is going to look like something times x plus or minus something times x plus or minus something equals 0. Then you'll use your zero factor property to set branch 1 equal to 0 and branch 2 equal to 0. For extracting roots, that looks like this. And then for the rest, you can choose which method you want. For number 113, I'm not going to show you exactly how to solve number 113, but I'll solve a similar problem. So the floor of a one-story building is 22 feet longer than it is wide. And the building has 1256 square feet of floor space. For part A, I'm going to write an equation for the area of the floor space in terms of the width. Here's my floor space. Call this dimension my width. And I know that my length is 22 feet longer than my width. So I can write that as W plus 22. So for A, I'm supposed to write an equation for the area of the floor. So area equals length times width. So area here is, the length is W plus 22, and my width is W. And this equals 1256. So now I'm going to distribute my W and get W squared plus 22W minus 1256 equals 0. And I'm moving the 1256 to the left side so I can have my equation equal to 0. That's my answer for part A. I'll just get you started on number 114. Number 114 has a gardener with 100 meters of fencing trying to enclose 350 square meters of garden. So the layout of the two side-by-side plots is two rectangles side by side. So I can call all my horizontal segments, which will be the same size. These are each going to be X meters long. And my vertical segments, these are all going to be the same size as each other. And so I'll call them Y. That's 4 of the X lengths and 3 of the Y lengths to equal 100 meters. And I can also make a formula based on area. So area equals length times width. So the area that I'm trying to enclose is 350. And my length here is 2x. And my height here is y. So 2xy equals 350. My strategy here is to get one of my variables isolated so I can substitute into one of these variables. For 116, I'm trying to construct a box with volume equal to 576 cubic centimeters. So my base of the box is X centimeters. And I'm going to cut out a 4 centimeter notch from each corner to fold up and make the box. So here for volume equals length times width times height. So that's length and width are both X and height is 4 centimeters. So that's 4x squared is my volume, and that's 576. So I'm going to calculate my value for x here. Then I'm going to use the rest of my diagram. This distance here is my base. So I'm going to use this x and the fact that each notch is 4 centimeters to find the dimensions of my original box. And since it's a square piece of material, you can just answer with the length of one side. For number 119, I'm going to use my position equation. For an aircraft, flying 550 feet over level terrain drops a supply package. So for A, I want to say how long will it take for it to strike the ground. I'm going to start with writing my position equation. So position S is minus 16 t squared, t is time, plus my initial velocity times t, plus my initial position. So if I call the ground height 0, that makes my initial position 550. This initial velocity is 0, so even though I have level flight in the x direction, my velocity initially in the y direction is 0. So rewriting this as ground is 0, s is 0, equals minus 16t squared plus 0. S sub 0, or initial position, is 550. I can use this to solve for t. For part B, horizontal velocity is 138 miles per hour. How far horizontally will the package travel after it's released? So the formula I'd like to use here is my formula for distance. So the definition of Distance is rate times time. I'm given a rate and I've calculated my time. So for distance, I'm just going to multiply my rate is given in miles per hour, but I solved for t in seconds, so I need to convert hours into seconds. So 1 hour is the same as 60 minutes. 1 minute is the same as 60 seconds. So I can cancel my hours. I can cancel my minutes. And that gives me 138 over 3,600 miles per second. I'm trying to find my distance, so I can multiply my 138 over 3,600 miles per second times my time, which is in seconds. For 120, we're going to drop a coin from the top of the Eiffel Tower. So our initial position is the top of the tower is 984 feet. So for part A, we're going to use the position equation to write a mathematical model for the height of the coin. So since we're dropping the coin from rest, our initial velocity is 0. So we can rewrite our position equation using these values for V0 and S0. For part B, we're going to find the height of the coin after t equals 4 seconds. And then for part C, how long will it take before the coin strikes the ground? So we're using 984 feet as our initial height, and so we'll use 0 as our final height. Height above ground is 0, so when does this equation equal 0? So you're solving this for the zeros of the equation. For 121, we're going to throw a baseball straight up in the air at 100 miles per hour, starting from a height of 6 feet 3 inches. When using the position equation, remember that distance is measured in feet, velocity is measured in feet per second, and time is measured in seconds. So we're going to throw a baseball straight up at V0 equals 100 miles per hour. And our initial height is 6 feet 3 inches. So we need to convert both of those. We need velocity in feet per second. So you might remember that 1 mile equals 5,280 feet, and 1 hour equals 3,600 seconds. Also, for position, you need this purely in feet, not feet in inches. So you should remember that 1 foot equals 12 inches, and then you can do the conversions from there.